Hello everybody, welcome to my first video on differential calculus. And more generally, this video will be about functions because in order to master differential and later on integral calculus, we really need to get a good grasp on, first of all, what a function is, number two, how functions can be explained. By explained, I mean what valuable pieces of information can we use to gain a better understanding of our function, which will include domain, range, and intercepts. And thirdly, we must learn how to draw functions. In order to really get into differential calculus, which I'm sure most of you are here for, we really need to master these skills. So, let's begin. First of all, what is a function? And I may or may not be stealing from some of my teachers' first year calculus notes, but a function is, let's say, a rule that assigns an element into a set. Beginning with some notation, we use the following symbol to connote that x belongs to D. X belongs to D. This is a symbol that we will be using a lot, so it's pretty to D. This is a symbol that we will be using a lot, so it's pretty important that we get a good handle on what it means. X belongs to a group D, or X is a unique element of D. Moving on, I've chosen D for a strategic reason, and that's because D stands for domain. And domain means all of the X inputs that assign to an output in our function. Just change the thickness here. Much better. Let me give you an example, and I hope that will make things a little bit clearer. Let's take the following list of numbers. 1, 2, 3, 4, 5. And let's say 1 is Jose Bautista. 2 is Mike Trout. And in this case, notice how I'm not using numbers because a function really just assigns one input to one output. It may not even require us to use numbers. Let's continue. Bautista, Trout, Acuna. Ohtani, and and Devers. Let's say I had a function, and these were all of my inputs. So these here are my inputs. Can you think of what we would map as our output? If you thought team, then you were correct. Bautista was a player for the Jays. Trout currently plays for the Angels. Acuna, well, he plays for the Braves. Ohtani plays for the Dodgers. And Devers plays for the Red Sox. So really, a function, all it does is it maps an input to an output. And note how for each given input, there is one output. For a function, we need to have one input and one output. I'm going to reiterate this point. Because a list of numbers or even a list of names ceases to be a function once we have one input mapping to more than one output. In other words, each x is a unique element of D. So let's add another number. Let's add Betts. Well, Betts also plays for the Dodgers. And note how since we have one input mapping to, since we have two inputs mapping to one output, then this is no longer a function. So it's really crucial that we have only one input mapping to one output. As I said before, these terms here are make up the domain. In other words, the domain is the set of all inputs D of F. D of F. Now let's take a look at what this looks like when we add some numbers. Shall I give you some more numbers or shall I give you some more notation? Let's go with numbers. Let's get a ruler, because it's always great practice to use a ruler here. Okay. There we go. Not the greatest ruler, but that's okay. Let's get rid of the ruler. Okay, let's say we had the following numbers in a table. I'm just going to draw it myself. X and f of x. Let's say x was 2. Let's say x is 4. Hey friends, this is a message from the editor. I'm just jumping in. I use the notation or the letter f of x. And what that really means is, I don't know if I explained this, but I might. What this really means is that we're putting some x, so some number, in this case the numbers in the left-hand column, into our function. In the previous case, our function was team, what was kind of mapping a player to a team. In this case, we're going to see what our function is, or in other words, what happens to a number when we put it into a machine. Let's think about it as a machine. I hope you enjoy the rest of the video. Let's say x is 6. Let's say y is 4. or excuse me, f of x, note how I said that f of x is y. Because what we'll really learn is that f of x means y. You may have seen this before. F of x is equal to y. And we're going to get to see how that works. Let's say this is 8. Let's say this is 12. If we were to draw a graph using the following numbers, well, we'd see that 2, 4 is around here. Just say 2, 4 is around here. Let's say 4, 8 is around there. Let's say 6, 12 is around there.
Hey friends, John from the future. I'm going to pause myself once again. As a follow-up to my last point, you see f of x is equal to 2x. That's really what we're doing. Our machine in this case is not transforming player to team. In this case, it's taking each of our x values and multiplying by 2. Enjoy.
This forms a line. Beautiful, look at that line. And so this here is actually a function because we have one input mapping to one output. Is this a function? Well, if you said no, you're correct because our input, which we said was 2, maps both to 4 and also to, let's say 10. So when we have one input going to more than one output, we do not have a function. Now, I'll throw one more set of words at you. We know that all of the elements that belong to D, which we said was our domain, are here. These elements belong to D. Can you think of a way we can write that using our previous notation that we just learned about? If you thought that it looks like something like this, X is a member of domain D, then you're correct. And you may have seen this term range before. Well, and that's because the range is all of our y values, or our values for f of x. In other words, range is the set of all outputs of f. A cool way that we can kind of merge some of the notation tricks that we've learned is to do the following. Let's switch to a nicer color here. We can say that our range nice curly brackets. I'm sure you can draw some better ones than I can. Such that X belongs to D. What this really means in English, well, let's break it down. These brackets we can ignore for now. Let's begin with f of, oopsies. Let's begin with f of x. Excuse me, we cannot ignore the brackets. In English, what we're really trying to say is we have the set all f of x, the set of all outputs. More colors, because why not? The set of all outputs such that X belongs to the domain.
Hey friends, to confirm, that line in the middle means such that. It's a short form, just as writing the plus sign is a short form for plus and the equal sign is a short form for equals. Such that is given by this vertical line. Enjoy.
And so this is a really big chunk of the notation that we need to become familiar with for this course. Let's recap. Let's see how much we got through. Well, explain what a function is.
Before I continue with the recap, just to reiterate if that wasn't clear, what we're saying with this notation is that, or specifically when we're talking about range, is that we're talking about the set of all y values. So all of our y values, if we go back up here, all of those guys in the right-hand column, such that x is a member of D. So we can only have these numbers if our x value is a part of the domain, if our x value is one of these three numbers. We can't have any number mapping to any output. We have to make sure that our input is a member of the domain, and that's what we're specifying with this notation. Last interruption. Take us home.
A minute to think about it for yourself. We use this example here to show that a function is a set of numbers. It could be words, letters, animals, such that each input maps to one output. The moment that two inputs map to the same output, that is that each x map two or more x's map to the same f of x, this no longer becomes a function. An output, then this is operator. And so, but the moment that two or more, so write that out however you like. That's something we need to become familiar with here. Okay. Scroll back up. We explain what our domain is. We said that our domain is the set of inputs, that belong to D. So domain really is a fancy way of saying these names here. Domain is also a fancy way of saying these numbers, because a list, what we're really doing is align the into f of x. Here's f of x, or outputs f of x. Output.
Sorry friends, just having some technical difficulties. One moment.
X, we get 8. Output, quick note, that belong to D. So domain really is a fancy way of saying these names here. Domain is also a fancy way of saying these numbers here. And it's a fancy way of saying these numbers here. And we hopefully by now are familiar with the notion of a function, of a graph. And so when we say domain, what we really refer to are the x values that will map to one given output. And to reiterate, the moment that we have one input mapping to more than one output, which in this case was our 10 that we added on at the end, we no longer have a function. Range. We discussed range. Range is a fancy way of saying all of our outputs, f of x. And just before I forget, let's make a quick note. When we write y is equal to f of x, well, what we really mean is that this is our output, and what we're doing here is we're running an operator. So when we put an x into our function f, it will spit out a y. Let's see how we did that above. When we put an x into f of x, we get 4. When we put an x into f of x, we get 8. And when we put an x into f of x, we get 12. In this case, the relationship is a line. Our f of x here would be 2x. Because when we put our x 2 into f of x, what we're really doing, when we have something like f of x is equal to 2x, what we're really doing is we're saying f of 2 is equal to 2 times 2.
Last interruption from future John. I think what I just said is a really, really powerful way to think of a function. Forget about the equal sign. And when in doubt in math, it's always nice to think in English. So what I said earlier was that f of x is 2x. And if we scroll up, we see that f of x really is 2x. 4 really is 2 times 2. And 8 really is 4 times 2. It's a really powerful way to think about a function. And I hope it will serve you well in your future math career.
This is an idea that we need to become familiar with to succeed and master differential and integral calculus. And to recap and to reiterate, for our range, we use a lot of fancy notation that it would be good if we knew. It's not the end of the world if we didn't. But we said that our range f, putting it all together, is f of x, our outputs, such that our x that we put into f of x is a member of D, our domain, which, like we said up earlier, is all of the possible x values, which can be numbers, letters, names, whatever we choose it to be. And drawing, I will leave for another video. We did get to a little bit of drawing. Intercepts we didn't get to. Let's put a box around that to say we need to get to that. But intercepts, I hope you're familiar with by this stage in your mathematical career. Thank you guys so much for your attention, and I will see you all in the next one. Peace.